Good morning, students. Now we are going to see the lesson electrostatics. First we will see what you have learned in the last class. What is the first heading you are prepared? Electrostatic potential at a point due to an electric dipole. So you are calculated the value of potential value is equal to V value equal to, remember the formula, P divided by 4 pi epsilon 0 R square. And here cos theta is there. You will assume cos theta value equal to 0, 90 or 180 degree. Then equipotential surface. The potential at the particular point. How many points you are selecting on the surface side or the layer side. All the potential values are equal, same. That is equipotential surface. Then the relationship between electric field and electric potential. E value equal to minus dV divided by dx. This is the relationship between electric field and electric potential. This class you are going to learn about electrostatic potential energy of a dipole in a uniform electric field. Then Gauss law and its application. Okay, the first one, electrostatic potential energy of a dipole in a uniform electric field. So, this parallel lines represents the uniform electric field. Already I told the distance between the lines are equal. So, that is parallel. Uniform field, the parallel lines. The electric lines of force are represented by the parallel lines. Inside the uniform field, place a dipole. What is dipole? Two equal and opposite charges. You see, one is a minus q, another one is a plus q. That is placed inside the uniform electric field. When it is placed inside the uniform electric field means what? Equal and opposite forces are acting. When how you will calculate the value of force? E value equal to F by Q. From this F value equal to Q into E. So, QE plus QE and minus QE is acting at the end of the dipole. So, that constitutes a torque. Okay. So, what is mean by torque? What is the formula you are calculated? Torque value equal to PE sin theta. Now, what is the use of this torque? This torque rotate the dipole inside the field. Okay. Now, I am taking the initial angle inside the dipole value equal to theta dash. Now, when it is rotating, the new angle value equal to theta. Now, which one you are going to calculate? You are calculating the value of potential energy equal to what? Now, how to calculate the value of potential energy? You know that potential energy and work done, both the values are equal. What is the formula for work done? Work done value equal to tau into d theta. For the small portion I am calculating, so I am integrating means I will get the answer for the whole value, whole system. How the angle is varying? Varying from the lower limit is theta dash, upper limit value is equal to theta. So the formula is tau external into d theta. What is tau external? Tau external is equal to tau e. What is tau e? Already you are calculated that value is equal to PE or P cross E. PE sin theta, or in the vector notation I am representing, it is cross multiplication, cross product. Okay. So this is PE sin theta, otherwise it is P cross E. Okay. Now, tau external value is equal to modulus of P cross E. Why I am writing here modulus? No negative symbol. For that here modulus in this side. So W value equal to, I am substituting the value of P cross E is equal to PE sin theta. So with respect to theta you are integrating. So the dipole moment value is constant. E value is constant. Inside the integration I will get only sin theta multiplied by d theta. When you are integrating sin theta, what answer you will get? You will get minus cos theta. Okay, so when you are getting minus cos theta, so W value is equal to PE. When you are integrating, the answer is equal to minus cos theta. What is the limit? Upper limit is theta, lower limit is theta dash. When you are integrating, when you are substituting the limit, what you will do? Upper limit minus the lower limit. So the first one, PE upper limit, so minus cos theta. The second one, minus of, so minus into minus is plus, PE cos theta. Okay, so cos theta dash. So this is the first term, PE cos theta dash minus PE cos theta. This is the difference in the potential del U. So the work done is equal to potential difference between two angular position theta and theta dash. Okay, now when all the already I told you the formula end with theta means you will substitute the value of theta value equal to 0, theta value equal to 90. Now I am substituting theta dash value equal to 90 degree. Then U of theta dash value equal to PE cos 90. Cos 90 value is equal to 0. So what is the total energy I will get? Only minus PE cos theta. So the formula is P dot E cos theta. Cos theta, how you will replace? It is a dot product. So it is P dot E minus P dot E. Otherwise the value formula is equal to minus PE cos theta. Now I am substituting theta value equal to 180. What is the value of cos 180? Cos 180 value equal to minus 1. So minus of minus, I will get the value is equal to plus. So this is the maximum value of potential energy when it is theta value is equal to 180 degree, pi or 180 degree. When I am assuming theta value equal to 0 here, when I am assuming theta value equal to 0, when I am assuming theta value equal to 0, what answer I will get? When theta value equal to 0 means cos 0 value equal to 1. So cos 0 value equal to 1 means the potential energy I will get minus PE. It is a negative value. So the value is minimum. Okay. Now the next one is electric flux. What is mean by electric flux? The number of electrons, how many number of electric lines of force are crossing the junction in a particular, crossing the system in a particular area, that is electric field. How many lines are crossing, that is called electric flux. Okay, now how you are representing the electric flux? Electric flux is represented by pi e. What is the unit of electric flux? Nm square c power minus 1. It is a scalar quantity. Now electric flux, what is the formula for electric flux? Pi e value equal to Ea cos theta. So E, what is the formula? E value equal to force divided by charge. So the unit is Nc power minus 1. Area, the unit is meter square. So the unit of electric flux is Nm square c power minus 1. Okay. Now you see the diagram. I am taking two areas. One is A, another one is B in this side. You see area A, that means the first case A side, number of lines are crossing the particular area is greater. Compared to B, the value is greater. When A value is number of lines are crossing the junction is greater, means the electric field E value is greater. Electric field E is greater means the flux value is greater. Compared to B, you see B side number of lines are less, then E value is less, then the electric flux in the which side, B side is less here. Okay, so the number of lines value is greater means which is greater? E is greater. If E is greater means the flux value is greater. Okay, remember it. Now I am calculating the value, three different cases. Electric flux value is equal to what? Remember the formula, electric flux value is equal to Ea cos theta. So the first case, I am assuming, you see the diagram, in the first case both are parallel, then the theta value equal to 0, then I will get the electric flux value is equal to E into A. You see the second case, it is normal, perpendicular here. So the flux value, theta value equal to what answer I will get here? It is 90 degree, cos 90 is 0. So the electric flux value is equal to 0. Now, it particular angle, it fixed particular angle theta. Then the formula is equal to Ea cos theta. This is the third case. Okay. Now, electric flux in a uniform, non-uniform electric field, how to calculate the answer. Now, you are calculating the electric field in a non-uniform field. You are taking the area is A and it is divided into small segments. I am taking del A1, del A2, etc. up to del AN. So, I want total flux means what I will do? I will add all the values. E1 multiplied by del A1, E2 multiplied by del A2. Like this it is going on. Otherwise, with the help of the summation, I will write the formula. Summation of I value equal to 1 to n EI into del AI. Okay. So, now what is the formula? General formula for electric flux? Flux value equal to inside the integration E into dA. This is the formula, or EdA cos theta. Okay. Now, electric flux for the closed surface I am calculating. When I am calculating the value for the closed surface, you see it is the object is placed inside the non-uniform electric field. Now, the angle between dA and E. So, dA it is a vector and E also a vector. It is less than 90 means the flux value is positive. Okay, the angle is less than 90 means the electric flux value is equal to positive. It is greater than 90 degree means the flux value is negative. Okay, so now the value is equal to, that means pi E value formula is equal to E multiplied by dA. Okay, the electric flux value, if the electric value is negative means the electric lines of force, or you see it is entered inside the closed surface. The flux value is positive. Electric lines of force are moving or away from the, leaving from the closed surface. This is the second one. Okay. Now, what is the next heading is what is Gauss law, state Gauss law. So, you are learning about now Gauss law. So, Gauss law, the formula relates which one? Now, this Gauss law relates electric flux and the total charge in the system side. You know the formula for electric flux. Phi value equal to E dot A in a closed surface. So, you see the integration side, small circle is there, that represents in a closed surface you are calculating the value of electric flux. So, E dot dA, otherwise that is written as E dA cos theta. Dot product means you will write as a cos theta. So, E dA cos theta. Okay. So, now here pi E value equal to E dA. Now I am assuming the theta value, maximum the value with theta value equal to 0, that is aligned with the field, theta value equal to 0. So cos 0 value equal to, you will get 1. Then the formula for pi is equal to E dA. Okay. Now, how to calculate the, how to derive the formula of derivation for the which one? Gauss law, how to calculate the value. Now, pi E value equal to, which is a variable one, the area is a variable one, that I am keeping inside the integration. You take E value outside. Okay, you know the formula for E, dipole side you are calculated the formula for E equal to 1 by 4 pi epsilon 0 Q divided by R square. What surface you took? You are calculating in a spherical side. The formula for the area of the sphere is equal to 4 pi R square. So, dA value equal to 4 pi R square. Substitute both the value dA value and E value in the equation side. So, what I will get? Pi E value equal to 1 by 4 pi epsilon 0 Q by R square multiplied by 4 pi R square. Denominator R square and the numerator R square cancel. 4 pi and 4 pi cancel. What is the remaining one? Only the term is pi E value equal to Q divided by epsilon 0. So, this is Gauss law. With the help of that, you write the definition. See, now the electric flux in the closed system is equal to 1 divided by epsilon 0 times the net charge present in the system side. Okay, this is Gauss law. Pi value equal to Q divided by epsilon 0. Okay, now the next one. How to calculate the value in the system side. I am taking different area side, how to calculate the value. QE value equal to closed integration of E dot dA, or E, that value is equal to what? Q divided by epsilon 0. Q end. What is the meaning of Q end? How many number of charges are present inside the closed surface? Only that will contribute for the flux. Okay. The discussion. What are the things you want to remind in the when you are calculating the value of electric flux, Gauss law? The total electric flux through the closed surface depends only the charges enclosed by the surface. How many number of charges are inside only that contribute. The charges present outside that won't contribute for the flux calculation. That is the second one. Now the third one, the total electric flux is independent of the location of the charges inside. Now this is the charge is present at the center or the corner, not like that way. It is in the east or west, not like that way. It is independent of the location of the charges inside the closed system, because outside will not contribute. Then the Gaussian surface is a imaginary surface. Okay, this is not a original one, it is a imaginary surface. We are assuming the Gaussian surface. It is a imaginary surface. You know, Q end means what I told you, charges, how many number of charges are present inside the closed surface. Gauss law is another form of Coulomb's law. That remember it, it is another form of a Coulomb's law. Okay, now what are the applications of Gauss law here? We are going to see a few applications here. The first one is we are going to calculate the value of electric field due to the infinite, that means infinite straight conductor, long straight conductor. You are calculating the value of what? You are calculating the value of electric field. You see the diagram, this is an infinite length current carrying charged conductor here. The length of the wire I am taking, that value is equal to L. Okay, now the lambda is what? Linear charge density. What is the value of linear charge density? What is the definition? Charge per unit length. Okay, now I am calculating the value of Q, means what I will get? Lambda multiplied by length, that gives the value of Q, charge value equal to what? Now you are selecting a point at a distance or from the which one? The wire, which one you are going to calculate the value of electric field. Now the next one, now we are calculating that means you are assuming the cylindrical Gaussian surface. You see two area I am taking, one is A1 and another one is A2, both are equal distance from the point. Okay, when I am calculating the electric field with respect to these two elements, you see both are acting in the opposite direction. Okay, so both the points are radially away from the charged wire of the magnitude of the electric field. Okay, but the distance value is both the sides, the radius is equal to R only. There is no changes in that side. Now you are assuming what I told you, you are assuming the cylindrical Gaussian surface. What is the radius? The radius value equal to R, the length of the cylinder value equal to L. You are calculating the value of total flux in the closed surface. Okay, how to calculate the total flux in the closed surface? Now I am dividing into three components. One is the upper cap, top surface, another one is the bottom surface, cylindrical side, and the third one is the curved surface area. Okay, so I want the total flux, means here pi into, that means in the closed integration of E dot dA. Okay, for the integration, the first one is for closed surface, the second one is for the top surface, and the third one is for the bottom surface. Now you see the diagram. For the closed surface side, how to calculate the value? E value is in parallel to A. You see here E value, the closed surface for the curved surface. The electric field is parallel to A. So you will get answer. Parallel means what? You will get theta value equal to 0 degree. So the formula for flux is equal to E dA cos theta. When theta value is 0 means the value is equal to 1. So E into dA. This is for closed surface. You see the bottom side and the lower side, lower bottom and the top and the bottom side. Okay, now top side and the bottom side, you see both are perpendicular perpendicular here. When it is perpendicular means what is the value of theta? Theta value is equal to 90 degree. When theta means 90 degree means cos 90 value is equal to 0. So you won't get the value of E dot dA. So what is the formula now? The formula is reduced to only for the closed surface here. So E into dA value is equal to Q by epsilon 0. What is the value of Q? Q value equal to lambda into L. So substitute the value here. E is common, that means a constant value, only the integration with respect to the area. So E into area value is equal to lambda L divided by epsilon 0. Now which one you are calculating? You want E value equal to what? So dA value is equal to, it is a curved surface area of the cylinder is equal to what? 2 pi RL. So E into 2 pi RL value equal to lambda L divided by epsilon 0. So what all the things are common, that all cancel. L value here, L value cancel. Okay, so I want calculate the value of E means E value equal to lambda divided by 2 pi or epsilon 0. So this is the value of electric field, and this is the vector representation of the electric field. E value equal to 1 by 2 pi epsilon 0 lambda by r into r cap. R cap is a unit vector. So this formula side you see the electric field is due to the infinite charged wire depends upon 1 by r. You see the formula, remaining all the values are constant. Lambda is constant, 2 pi epsilon 0 is constant. So that depends upon only 1 by r. Students, this class you have learned about electrostatic potential energy of a dipole in a uniform electric field. Then electric flux. And the last one is Gauss law and its applications. Okay, revise the portion and play Kahoot. Thank you, students.